Okay, so today we are talking about goals 13, 14, and 15, and we are looking at compound interest and depreciation. So when you deposit money into the bank, it earns interest. So that means the bank pays you a certain percentage of the money that you've deposited just for keeping your money there. It's like a reward for keeping your money at that bank. So the bank pays you for putting your money in the bank. That's called interest. That interest is called compound interest when you gain interest on your interest. So for example, say you deposit $100 at 10% interest. When your period is up, you're going to earn $110. You're going to have the $100 that you deposited and then 10% of that. So you'll earn $110. The next time your interest gets compounded, you're going to earn 10% of the $110. So you're earning interest on your interest, and that's called compound interest. We can do tons of computations involving compound interest using this formula. So FV, future value, that's the amount of money that you're going to have after a certain amount of time, equals present value, the amount of money that you initially deposit into the account, times 1 plus the interest rate, so that's R, that will always be in a percentage. So you could have 5% interest, you could have 2% interest, you might have 20% interest if you're really lucky. The higher that number is, the more interest you're earning, so the more money the bank is giving you for keeping your money there. Divided by 100 times K. K is the number of compounding periods per year. And you'll see down here that different accounts at different banks will compound their interest different numbers of times per year. So your interest might be compounded monthly, in which case K is equal to 12. They're going to compound your interest or calculate your interest 12 times per year. Could be quarterly, half yearly, annually, and each of those correspond to a different K value. The more often the bank pays you interest, the more money you're going to make in the end. Because you're paying interest, or they're paying interest on top of the interest that they've already compounded. So the more times they do that in a year, the better off you are. And then all of that is raised to the power of K times N, where N is the number of years that you have your money in the bank. So let's take a look at what that looks like in a real world problem. So here we have Hannah. Hannah places $2,000 in a bank account that pays 8% PA. This means per annum. That means over the course of the year, Hannah's going to make 8% interest on her investment here, per annum. Per year. And it's compounded quarterly, so 4 times per year. And the question is asking how much money Hannah will have after 3 years. So let's set that up using our formula here. FV, future value, equals present value times 1 plus our interest rate divided by 100 times K, the number of compounding periods per year, to the power of K times N, the number of years. So my future value is what I'm looking for. I don't know my future value. I'm looking for the amount of money that she'll have after 3 years. My present value is the amount that she originally invests, so $2,000. My R value here, my interest rate, is 8. It's paying 8% interest. My K value is the number of compounding periods per year. This particular account is compounded quarterly. So every year they're going to compound interest 4 times. My N value is the number of years. And it says that we're looking for how much money she has after 3 years. So plugging all of those values in here, I have FV, future value, equals $2,000 times 1 plus R, which is 8, divided by 100 times 4 to the power of 4 times 3. Simplifying that just slightly, I have FV equals 2,000 times 1 plus 8 over 400 to the power of 12. Would never expect you to be able to do that in your head, so we're going to take out our calculator for this one and plug it in. So here we go, we're looking at 2,000 times 1 plus bracket 8 divided by 400. Close both my brackets there to the power of 12. So Hannah is going to end up with a future value of $2,536.48. So that's how much money is going to be in her account, providing she doesn't take any out or put any in, after 3 years of collecting interest. Sometimes questions will ask, how much interest has she earned? And the calculation is very simple. If we take the amount that she has after 3 years, $2,536.48, and we subtract from it the amount that she herself deposited into the bank, we're going to find the amount of money that the bank has paid her. That's going to give us $536.48. So this is the amount of money the bank has paid her in interest, and this is how much money in total she has in her account after 3 years. So that's a quick example of how to do it using the formula. However, in math studies, we're really lucky that we're able to use this tool called the time value of money solver. So in our TI-83 or TI-84, we have this tool that does all of these calculations for us. We just need to know what to enter. So if I go to Apps, this purple button, and select Finance, you may have more options here on your calculator, but I'm going to select Finance and TVM Solver, Time Value of Money. It brings up a screen that looks like this. And we have all of these values that we need to input. So I'd like you to take some notes here on your workbook of what each of these values corresponds to. So N is the number of years. So that's the number of years that you have your money in the bank. I percentage is your interest rate. Say if your interest rate is 8% per annum, you're going to enter 8 there, not 0.08, but 8. Your present value is the amount you initially invest. So that's the amount that you're depositing in your bank account at the beginning. PMT, we're not going to change that. We're going to leave it. Future value is the amount you have at the end of n years. So after 3 years, say, if your end value is 3, you're going to have your future value left in there. P/Y, we don't put anything here. C/Y is our compounding periods per year. And then our PMT, we don't put anything in there either. So let's take a look at what that looks like in an actual example. So Hector deposits $6,000 in a bank account that pays 5% per annum, compounded monthly. How much will he have in his account after 2 years? And I want you to solve this using the TVM solver. So what we need to think about here is what we're going to plug in for each of these values. So N is going to be the number of years, so we're looking at the amount after 2 years. I% is our interest rate, so we're working with a 5% interest rate here. Present value is $6,000 because that is how much he is depositing before we start calculating the interest. PMT, we're going to leave at 0. Future value is what we are looking for, so we're actually going to leave that at 0 for now too. But that's the value that we want to find. We want to find the value of his money after 2 years. PY, 0. Compounding periods per year here, we're compounding monthly. So they're going to be 12 compounding periods per year. And don't touch this one, just leave it. So plugging that stuff in here, I get 2. My interest rate is 5%. My present value is $6,000. PMT I leave at 0. Future value I leave at 0 for now. And my compounding periods per year is 12. So when I go back to my future value, in order to solve this, I need to press the alpha button. That's this green button here. So to solve, I need to press alpha, then enter. So when you press alpha, what that does is change all of these buttons to the value of the green above there. So you can get all of the letters of the alphabet here, and you can also get this green value here, which is solve. And that's what we want to do. We want to solve for the future value. So we're pressing alpha and then enter here. And that gives us a future value of negative $6,629.65. We ignore the negative there. For some reason, either your present value or your future value has to be negative in the TVM solver, but that's above our heads. We don't need to know why, and we don't need to leave that negative. So our future value here is going to be positive $6,629.65. And that is how you solve using the TVM solver. It's way easier, no chance that you're going to make any algebraic or arithmetic mistakes there. So looking at this one, Lauren's parents give her $8,000 to buy a car, but the one she wants costs $9,200, so she's a little short there. She deposits the money in an account that pays 6% per annum compounded monthly. We need to know how many months it will take until she has enough money to buy the car. So let's take a look at what we're going to enter into our calculator here. For n is the number of years. Do we know how long she's going to leave her money in the bank? No, that's what we're trying to find. We're not sure how long it's going to take her to get $9,200. The next value here in our TVM solver is interest percent. And we're looking at 6% interest, so that's going to be 6. Her present value is going to be the $8,000 her parents have given her to buy the car. Her future value here is $9,200. That's how much she eventually wants to have. But we need to make that negative. And that's really important. One of those values always has to be a negative number. Doesn't matter if it's present value or future value, but one of them needs to be a negative number. Finally, we're looking at compounding periods per year, and we know that this is going to be compounded monthly, which means our number of periods here is 12 per year. So let's enter that in and see what we can find. So our n value, we'll leave that at 0 because we don't know it yet. Our I percent is 6. Our present value is 8,000. And we're going to enter our future value as negative 9,200. Compounding periods per year is 12. And we're going to scroll back up here to n, and it's alpha, enter. That gives us 2.3351842 years that it's going to take her to get her car. However, we weren't asked for years, we were asked for months. So in order to find months here given years, what we need to do is multiply that by 12, because there are 12 months in a year. So I can do that on here as well. Multiplied by 12. And that gives me 28.022 months. So if we're looking for whole months, it's going to take her 29 months in order to have $9,200 in the bank. One last example of depreciation. So depreciation occurs when objects lose value over time. So you've probably heard the saying that when you buy a new car, the moment you drive it off the lot, it loses 10 or 15% of its value. So that's depreciation, that loss of value. And everything that you buy, except for maybe Beanie Babies, depreciates in value over time. So to calculate depreciation, all we do is enter our interest rate as a negative value. Oops. So our interest rate is going to go in as a negative value. So here when we're looking at this example, a truck was purchased for $110,000 and depreciates at 20% per annum. How much will the truck be worth in 10 years? So my end value here is going to be 10. My interest rate percent, because it's depreciating at 20%, is going to be negative 20. So because it's depreciation, that's where this negative comes in. Our present value, how much the truck is worth now, is $110,000. Must be an expensive truck. Our future value is what we're looking for. And when we look at compounding periods per year here, we just have one because it's depreciating at 20% per annum or 20% per year. So that is only compounding once per year. So plugging that in here, I have apps, finance, TVM solver, number of years is 10, interest rate is negative 20. Present value is $110,000. Don't worry about PMT. I'm not sure what my future value is, and my compounding periods per year is going to be 1. So I scroll back up to my future value, and I'm expecting this value to be a lot lower than $110,000 because this truck is losing value. It's going to become less valuable. It's going to be worth less money. So I'm going to alpha, enter, and that gives me a future value, remember we ignore the negative, of $11,811.16. So after 10 years, that truck has gone from being worth $110,000 to $11,811.16. So that's depreciation.